Okay, so in lesson 9-7.3, we're going to talk about how to solve systems of equations using substitution. In order to get started with that, I've made a little example here. Think of the equation y plus x equals 25 and solve for x when y equals 13. Well, when we have a problem like that, all we do is substitute 13 in for y. And so then we have 13 plus x equals 25. Okay, so this is called substitution. All right, and then to solve for x, we need to then get x by itself by subtracting 13 on both sides. Okay, I can draw my line, bring my x down, bring my equal sign down, and I'm left with 12. So x equals 12 when y equals 13. Okay, so this is an example of using substitution. So we can solve systems of equations in a very similar way. For example, we have y plus 2x equals 36. Now, that's one of our two equations. It says solve for x when y equals 3x plus 2. So this is like another equation. So we have one equation here, and we have another equation here. Okay, so what we're going to do is we're going to substitute in y, this y value. Okay, it's actually an expression, 3x plus 2. It's not just a number like we had before. We're going to substitute that in for y, and then we're going to solve for x. So let's rewrite it. So y is not y anymore. Now it is 3x plus 2. And then we still have the 2x. Okay, so now I'm just bringing this down, and then it equals 36. Now what I need to do is just follow my rules of algebra, and I need to combine like terms. So, simplify both sides of the equation. So 3x and 2x makes 5x. So I have 5x plus 2 is equal to 36. Now we have a two-step equation. We need to undo addition and subtraction. Subtract 2 on both sides. Okay, I can draw my line. I need to bring my 5x down. I bring my equals down, and I'm left with 34. Okay, now I need to divide by the coefficient, which is 5, and then x is going to be, we're going to get a decimal for this, but we can make 6 whole, and there'd be 8/10, so 6.8. Now, of course, we can check this. Now, we haven't completed our problem yet because, remember, our solution is always two numbers. It's your x value, 6.8, and it's our y value. So we need to actually take this number right here, and we need to plug it into our equation to find out what is y. Now, you can just pretty much do that with a calculator, but we can take y equals 3 times 6.8 plus 2. So 6.8 times 3, or 3 times 6.8, and then add 2, and we get 22.4. Now, of course, this is your solution, but we can plug those in and check. So let's take our y value, 22.4, plus 2 times 6.8. And when I add that all up, I do get my 36. You can check it by taking your answers, taking your x value and your y value, plugging it in, and it should work for you. Okay, so that's an example of solving a system of equations using substitution. So we didn't have that example. Now we need to go ahead and add these to our notes, or add the last page in there. It would be nice for you to have those in your notes. So substitution is a method of solving a system of equations in which one equation is solved for a variable, and then this expression is plugged into the second equation. So step one, we need to solve one equation for one variable. So you think about how we started here. This one was solved for y. Okay, we don't need this one in slope-intercept form if we have this one solved for y already. Okay, so it kind of saves us some steps there. In some problems, this may already be done, just like in the one we just had. Step two, plug the expression from step one into the other equation. So the second equation should now only have one variable. So again, we know that if you have one variable, there's only one solution. All right, step three, it says solve the equation from step two for the missing variable. And then step four, substitute the value of the variable obtained from step three into either equation to find the value of the other variable. So So when we're done, we need to have both an x and a y variable. Okay, so let's do an example here. So this one is solved for y. Y equals negative 4x plus 20. So what we can do is we can take this y and we can substitute it in right here. Okay, so let's rewrite it. We're going to go 4x minus 2 times the quantity. Now I'm just going to enter this expression. So I'm going to go negative 4x plus 20. Okay, now it's going to be equal to 20 still. All right, so now I only have an x variable. I only have one variable, and when you only have one variable, we only have one solution. Okay, at this point, we need to follow order of operations. All right, so we can go ahead and distribute this throughout the expression. So I'm going to still have 4x. Now remember, this is a negative, so negative 2 times negative 4 is positive 8x. And then a negative times a positive is negative 40, and that is equal to 20. Okay, and so right now we can combine like terms. I have 4x and 8x, so that makes 12x minus 40 is equal to 20. And now we need to get rid of the addition and subtraction, so let's add 40 to both sides. All right, and then we can bring our 12x down. This is going to be 0. We bring our equal sign down, and it's going to be equal to 60. Okay, let's extend our page a little bit here. Now we need to divide by the coefficient of 12 on both sides, and so that's going to cancel there. So x is going to be equal to 5. 60 divided by 12 is 5. All right, so now we're not quite done yet. Now we need to take that 5, and then we need to go back up to our first equation, and we need to plug it in right here. So we need to put 5 in right there. So let's go y equals negative 4 times 5 plus 20. Okay, so y is going to be negative 20 plus 20, which y is going to equal 0. So my value for my solution is going to be 5, 0. And that is where those two lines are going to meet. Now, so I just solved that without having to graph it. Yes, there was, kind of a lot of work there, but, I didn't need to actually make a graph, and I didn't need to plot all my points and figure out what intervals to use. So it is kind of a nice way to do it. So it works really well when you already have one of the two equations set up, ready to solve for one of the variables. All right. So this one starts with y equals 3x minus 1. What I'd like you to do is pause the video. I'd like you to work this one out, see if you can get it, looking at our last example, and then you can go ahead and press play, and I'll work through this problem. All right, now that you worked through it, let's go ahead and check to see how you did. So here's y equals 3x minus 1. We can substitute this value, this expression, in for y up here. So let's rewrite it. We're going to go 3x minus, and now I'm going to put 3x minus 1. Now, it is important to put this whole thing inside parentheses, okay? Because remember, this negative, this subtraction is outside, okay? This whole thing is my y. So in reality here, we're going to have to distribute that negative within. So that might have been a step that you might have left out, which is fine. We can get it taken care of now. So this negative here, we need to distribute it throughout. And so we're going to get 3x minus 3x. Okay, negative times the negative is plus 1 equals 1. Okay, well, take a look here. I have 3x minus 3x. Well, that's going to be 0. Those two actually cancel each other. And so I'm left with 1 is equal to 1. Okay, well, let's think about what that means. If 1 is equal to 1, then that means that, that it is true. Okay, this is true. It's not like 2 is equal to 1. So if 1 is equal to 1, that must mean that what we have here is we must have infinite solutions. Okay, and the reason it's infinite solutions, we can check that here real quick by if we solve this one in slope-intercept form. Okay, let's subtract 3x. Let's write it up here. 3x minus 1 equals 1, or minus y equals 1. And then let's subtract 3x from both sides. So we're going to get negative y is equal to negative 3x plus 1. And then if we divide everything by negative 1, we're going to get y is equal to positive 3x minus 1. And so you take a look, y equals 3x minus 1, y equals 3x minus 1. They're the same equation. So if you ever solve this and you get 1 equals 1, that means that we have infinite solutions because these two things are the same line. Okay? So there are an infinite number of solutions. That's what that means. All right, so let's try another one here. We have y equals, so this one's already solved for y, so let's take this value, this whole expression, and let's plug it in for y. So let's go negative, I'm going to do it right here, we'll go negative 3x minus, I'm going to put it in parentheses, so whenever I substitute, I always put it in parentheses, so negative 3x plus 8, and that is going to equal negative 5. Okay, so again, this is my equation I'm plugging into. So there's the negative 3x, here's my minus, now I put it in parentheses, I got negative 3x plus 8, and then here's equals negative 5. Okay, so now I only have one variable. Now I do need to distribute this negative sign, so I'm going to go negative 3x, I'm going to go plus 3x, because a negative times a negative is a positive, and a negative times a positive is a negative 8. And that equals negative 5. Now, take a look here. I have a negative 3x and a positive 3x. Those two things are going to cancel again, just like last time. But here I get negative 8 is equal to negative 5. Now, that is not true. So what do you think we're going to have for an answer here? What we have is we have two parallel lines. Okay? And so that's why we get negative 8 is equal to negative 5, because we have no solution, because it is not true. All right, so the last problem, we got 1 equals 1. That's infinite solutions because it's the same line. This one, we got negative 8 equals negative 5, which is a parallel line and no solution. Okay, so that's kind of the differences there between those two. All right, so now we actually have both of them set up being solved for y. And if both of them are being solved for y, it really doesn't matter which one we do. So what I'm going to do is I'm going to go ahead and take this y, and I'm going to plug it in right there. Okay? So I'm going to take negative 2x plus 1 is equal to 3x plus 16. Okay? So since they're both equal to y, then they must be equal to each other. Okay? So it's like if A equals B and B equals C, therefore, A must equal C. Okay, so if this equals y and this equals y, then they must equal each other. So that's what we did here. We wrote them equal to each other. Now, remember when we did this, you want to pick the smaller number. So anytime you have a negative and a positive, always get rid of the negative, because then we'll be left with a positive. So if I add 2x to both sides, okay, I draw my line, all right, I'm going to be ended up with my 1. My equal sign. I'm going to have 5x, and I'm going to bring my 16 down, plus 16. Okay, now if I would have went the other way, it would have worked, but I would have got negative 5x, and I'd rather work with a positive. So now I'm going to subtract 16 on both sides. Okay, so I'm going to bring my 5x down, bring my equal sign down, and this is going to be negative 15. Now I'm going to divide by 5 on both sides, and I'll be left with x is equal to negative 3. Now, I'm not done yet, because right now I'm going to need to plug this value in for this x. So I'm going to take my negative 3 and put it right in there. So we're going to go y is equal to negative 2 times negative 3 plus 1. So y is going to be a negative times a negative is a positive, so that's 6 plus 1, and y just equals 7. So my solution is negative 3, 7. And I like to write my answer as an ordered pair because, you know, it relates back to us when we were graphing. And that is really where it happens. If we were to graph these two lines, they would intersect at the point negative 3, 7. All right, that's our last example for today. So I hope you enjoy learning how to solve systems of equations without having to graph using the substitution method.